This is Math 3, 4.4 homework notes. That's Math 3, Unit 4, Lesson 4. I'm going to do a few of them with you off the worksheet. Starting off with number 2. Because it's a single fraction on each side, we can just cross multiply. It says solve the following. State whether each equation has no real solution, one real solution, two real solutions, or infinitely many solutions. Okay, so we're going to cross multiply. X times x minus 1 equals 2x plus 7 times x minus 5. And I'm allowed to do this because there's a single fraction on each side. So I distribute, that gives me x squared minus x equals double distribute 2x squared minus 10x plus 7x minus 35, and then combine your like terms. X squared minus x equals 2x squared minus 3x minus 35. And then we do what we did in previous units and you learned last year, to get everything to one side. And I want my leading coefficient to be positive, so I'm going to move everything to the right. It doesn't matter which way you move things, but in this case I'm going to move everything to the right so that I could have it where my leading coefficient is positive. 0 equals 2x squared minus x squared is 1x squared minus 2x minus 35, and then this I can factor. I'm running out of room up there. 0 equals double bubble. It's going to be minus 7 and plus 5. Negative 7 times 5 is negative 35. And negative 7x positive 5x is the negative 2x. I set them both equal to 0 and I get positive 7 and negative 5 as my solutions. So 2 real solutions is what I have. 2 real solutions. Okay, the next one I'm going to do for notes is number 8. And this one, because it's not a single fraction, I'm going to cover this one over here. If it were like this, I could cross multiply. But since there's an extra fraction on either side, I cannot cross multiply. So here is what you do. You multiply everything by the common denominator. I'm going to factor this first. You're always going to factor first. So 6 over x minus 3 minus 6 over x equals 18 over GCF x minus 3. And here's what you do. You clear a complex fraction you clear a fractional equation just like you would a complex fraction. You multiply everything by the common denominator. I will repeat that. You clear a complex fraction. You've done this before, just not this complicated. You clear a fractional equation just like you would a complex fraction. And we've done complex fractions before. That's where you multiply top and bottom like these here. You multiply everything by the common denominator. That's what we're going to do here. We're going to multiply everything by the common denominator. So I look around, I have an x in common and an x minus 3. So I'm going to multiply every fraction by the x and the x minus 3. The x and the x minus 3. So I'm not trying to rewrite it with a common denominator. I'm just multiplying everything by the same thing and clearing it. I'm going to multiply everything, as long as I do everything on both sides of the equal sign by the same thing over and over and over, it's okay. What I'm doing to one side I must do to the other, so everything is staying equal. Okay, x minus 3 is gone, leaving behind a 6 and an x, so 6x minus the x is gone, leaving behind a 6 with an x minus 3. I'll have to distribute. The x is gone, the x minus 3 is gone, leaving behind just the 18. Once you do this step, you should get rid of your fractional equation. You should end up with just a regular equation with no more fractions. Again, once you clear this fraction, once you multiply everything by the common denominator, fraction should be gone. You have just a regular old equation because all of your denominators reduced. Okay, so 6x minus 6x plus 18 equals 18. Combine like terms, 6x and negative 6x is 0, so I'm left with 18 equals 18. If you end up with an equation that is true, like 18 equals 18, that means you have infinitely many solutions. All real numbers. You have infinitely many solutions. Now let's say you ended up with something like 18 equals 12. Let's say this over here, instead of 18 were 12. Let's just pretend that was a 12, that was a 12, and you ended up, don't write this down because that's not what it was, but let's pretend you ended up with this, 18 equals 12. That's not true. 18's never by itself going to equal 12. You would then put no real solution. But since what we were left with is true, 18 by itself will always equal 18 and all the variables are gone, then it's infinitely many solutions. Okay, next one. Same as this one, I need to factor and then clear. It says solve the following equations and check for extraneous solutions. What are extraneous solutions? Extraneous solutions happen where you don't make any mistakes in your work. All of your work is correct, but one of the solutions just doesn't work. It does not work. So you're thinking like, how does that happen? It does. That's called extraneous solutions. Okay, x over x plus 2 over, remember what I said earlier, we always factor first. And that factors to x plus 2, x plus 3. I'll put parentheses there, And here's what you do when you're solving fractional equations. We talked about restrictions on a previous lesson, and we only did very few of them, and I told you then we'll do them again when we need to. Now is the need to situation. Whenever you're solving and there's variables at the bottom, you have what we call restrictions, things that x cannot equal. X cannot equal negative 2. Why is that? Because negative 2 plus 2 is 0. Negative 2 plus 2 is 0. X can also not equal negative 3. Why is that? Because negative 3 plus 3 is 0, same here. Negative 3 plus 3 is 0. So these are my restrictions. They may not even matter. I don't know if I'm going to need those restrictions or not until I solve. Sometimes these restrictions don't even matter. Sometimes they do. We don't know until we solve. All right, I'm going to multiply everything by the common denominator, which is x plus 2, x plus 3. They have an x plus 2 in a common, x plus 3 in common. I'm going to multiply everything by x plus 2, x plus 3. And you can make them over 1 just so they look like fractions. X plus 2 reduces, leaving behind x with an x plus 3, plus x plus 2, x plus 3 is completely gone, leaving behind a 2, equals x plus 3 is gone, leaving behind a 5, distributed to an x plus 2. I'll distribute in just a little bit. Okay, so the x plus 2 is gone, distribute the x squared plus 3x, everything distributed, leaving behind a 2. The x plus 3, and I meant to say reduced, everything reduced here. X plus 3 reduced, leaving behind 5 distributed, so you get 5x plus 10. We're going to subtract things over and find a common denominator. I'm sorry, and solve is what I meant to say. We're going to move things over and solve. So I have minus 5x minus 10. So I can get everything over to one side so we can factor and solve. X squared minus 2x minus 8 equals 0. 3x take away 5x is negative 2x. 2 take away 10 is negative 8. We are going to double bubble. X minus 4 and x plus 2. That gives me negative 8 at the end. Negative 4, positive 2 is negative 2. I solve by setting them both equal to 0. I get positive 4, negative 2. And here is where finally you get to check to your extraneous solutions here and see if, so let's say I forgot to check and I said, oh, that's my answer. I may get it wrong because according to this, x cannot equal negative 2. Now, I didn't mess up anywhere. Negative 2 truly comes out as one of my solutions, but it's extraneous because right here, negative 2 plus 2 is 0. Any number over 0 is undefined, so negative 2 is not going to work, which means positive 4 is my only solution. You're not going to know that doesn't work unless you wrote this down first. Let me get that in screen, sorry. Okay, so again, we end up with 4, negative 2. And the negative 2 doesn't work because of the extraneous solution over here. It said x cannot equal negative 2. If you made negative 2 an answer, negative 2 plus 2 is undefined. Is 0, and any number over 0 is undefined. So be careful with those extraneous solutions. X equals 4 is the only solution for this problem. All right, that is it for now. We'll do more like this in class together.